Okay, well, let's see if we can. I wanted to wrap up the STAAD exercise. We kind of rushed through it, as I remember, right at the end of Friday, and didn't really. I don't feel like I really ended it completely. So I wanted to show you a little bit better how to choose the final members, and then maybe a little bit more about the report. So the point we had gotten to, I believe, and we can look back, we had run an analysis, right? And the analysis should be for timber. I think it's already set up as timber, but that gets you into timber. I found you have to every time you go back and change some of the settings, you have to make sure. I mean, if you don't see, you should see this up here on the top, the AITC 1994. If you don't see that, you have to go back and reset timber, and sometimes it makes you. I mean, by default, I think it comes up by steel, and so it'll, as you go back to modify the file, it'll keep trying to throw you back to steel, and then suddenly you don't see the options that you want, but they're there. You just have to reset it to steel. I mean to timber. Okay. So then we ran the analysis. I think that's all there is to that. Did it run? I think it is running. Oh, I see. Yeah. Okay, it runs on my other screen here, so you can't see it. That's very convenient. So it ran, and you should not get any errors. So you always make sure you don't have any errors. If it warnings, sometimes it'll warn you if you've got too many end releases. It'll give you warnings about that are kind of a nuisance. Fortunately, I think we corrected all those, so we don't have that. The one warning I'm getting now is because I'm using the area command. And the area command they're trying to replace with the, I think there's a one-way command or something, but it's much more complex to use. And for this simple example, the area command works okay, so we're just going to use that. So that's all right. We've got those. You can view the output at that point. That's not a bad idea, except of course it'll come up on the other again on the other monitor over here. So let me see if I can try and drag it over. Okay, so here's my output. This is kind of like a table of contents here. You can jump immediately to the timber design section. Did I do that? Did it get there? No. Why didn't I do that? Guess you have to do it twice. Okay, and then this would take you through member by member, all the members that you do the code check on, and oh gosh, I forget if I set the code check for all the members. I think I did. You probably should. At one point when I was playing with this a week ago, I was thinking, oh, if you set the code check to all the members, you get a ton of results. I mean, you do get a lot to look at there. So I was trying to limit it to maybe only the critical members. Like on these beams, we've broken them up into how many segments. Every space between the joists is a separate beam. So it doesn't, I mean, although we grouped it into one, when it does the code check, it does it like, so you get a separate reading for each one. And I was thinking, well, let's just look at the critical ones in the center. I think maybe I put that in the instructions. But then I noticed the ones that were failing were not the ones in the fail. They were failing in shear for some reason out at the end. And you'd miss them then. So it's probably not a good idea. You should just do the code check for everything. And you'll get a bunch of results, but yeah, that's okay. And you can see each of these Let's try to get one that we can see here. So this is for member number 132, right? And it tells you the size of the member. This we already specified initially as 5 1/8 by 21 deep. This is the glue lamp, so 132 must be one of the beams. I'm not sure which one. And then it gives you all the bracing up here. It was braced at 16 inches on center, so that must be one of the, isn't that the bracing on the joists? These were 16 and these were 12, is that what that was? Anyway, so that's giving you the bracing, and then it gives you all these. Okay, the CD, which is not the load duration factor. They call the load duration factor CDT, I think. See if I can find it. I don't even see it. Oh well, yeah, I'm not quite. I may have to look that up to see. They give the names that STAAD assigns to them are not exactly the matching the NDS. So you kind of have to double check what it calls certain things, because sometimes it's not. Some of them it calculates itself, and some of them you have to input. Like CV would be nice if it would calculate CV. Well, I guess it can't because it doesn't know, it sees the beam as that long and really it's this long, right? And that total length goes into CV. So that's what messes up the CV calculation. So you've got to do that one, we've got to do ourselves. It does calculate for our brace, since our bracing is by all the joists, it'll have the correct length for the bracing, so it does calculate at least CL correctly. And then it gives you all these stresses. And it also tells you whether it passes or fails somewhere. I thought up here, oh, here it is, pass. So it does pass, that's good. This is the controlling code reference, and that is not the NDS. This is going by this one, the AITC. This was the older, back in 94, I guess this was commonly used, particularly for glue lam. This was really the reference. But now, not so much. This one's kind of fallen by the way, and the NDS has really taken over. But STAAD hasn't caught up with the rest of the wood community, I guess. We're lucky it does what it does. Okay, and the other thing that's interesting, this thing here, these are the names of them up here. This is the ratio. So, right. Oh, these must be the bending stress. Okay, interesting. The ratio is its utilization ratio, which is the ratio between allowable stress and actual stress. So if it's 1, you're right on the border. If it's over 1, you're failing. If it's under 1, you're passing. If it's way under 1, like 0.3, you've got you're passing. You're 60% over designed, right? 0.3 is pretty low. You should be up around 0.7, but it's showing it for, it could be a non-critical spot in the beam. I don't know what spot this is, so you have to really look at the critical spots to make any decision about the ratio. Okay, so that gives you a little bit of a view of that. Now, to really, what you want to do is try to size these members so that they are reasonably efficient, right? At least not failing. Oh, shoot, that's what I should look for, failing. All right, sorry. Let me go back. You can, that screen that was just up, the analysis, is this right here. So as long as it's active, you can pull it back up. And what I meant to do was look for failing members. And you can search for, I mean, if one's failing, it'll have the word fail on it. So that would be a nice term to search for. We could find all. Why not? Okay, lucky us. There's only one that fails. And we could, I think if you click on this, you'll jump there. There it is. The one that failed, and it is member 179. So I was almost there. 179 we'll have to go back and look at, but you could see how it fails. And this is the shear. I think it fails, if I remember, this was one that failed in shear. So here's the actual shear is 68 KSI, I guess, and no, PSI, I'm sorry, PSI. And the allowable shear is 63, so that's where it's failing. It just barely fails in shear. And it seems like we did this Friday, didn't we? We noticed one that was failing and upped the size of it, if I remember right. That was probably that one. So this is, you kind of remember 179, and here the ratio, you can see, oh yeah, it's only failing by 6%, right? So it just barely fails. So 179's got to get a little bit bigger. Other ones are maybe over-designed, but at least they're passing. So we could check. Let me get a view that I can see a little better. You can, let me see, does this give me a, oh yeah, how about that? That was a right click, I think. Structure diagrams, this thing here. And it's also up on the top there somewhere. Design results. Oh, first you could give it some well, let's just do design results. Well, I tell you what, let's look at the labels first. See where that one is. Well, this will tell us which one it fails. If you turn this on, design results, it'll tell you which ones fail. It marks them green and red, green for pass, red for anything that's failing. So we can apply that. And I also have this down here, show values. If you have it off, you don't see any numbers. If you turn it on, it'll show you the actual ratios. So, okay, I think I can close that. Here's my little red one. So that must be, I think that's the only red one I see. That must be the beam that's failing. So we want to up, I mean, obviously we've got to up the size of the whole beam, right? We can't just make it in that one little spot because it's the whole beam that's the problem. These other ones, we can kind of look at them too. These are the joists, I guess. It looks like they're, if I'm seeing them right, yeah, this should be the joist. This is the beam, this is the beam, this is the joist, rafters rather. So the rafters are, if that number is correct, are way over designed. They're only like at 10%. Okay, so they're way over designed at a 2x10. Maybe go down to a 2x8 or a 2x6. These are not quite so over designed. I think I had both of them as a 2x10 originally, right? So maybe we could make this one a 2x8 and this one a 2x6. You can try to use this ratio and as a actual guide to the next member you select, right? Like if we assume that the section if flexure is controlling, I could multiply the section modulus by that ratio, and it would reduce my section modulus, right? And I could go to the table and pick it by the section modulus. So you could actually pick it like that. In the case of the joists, there are not that many choices, right? I mean, we're not going to go less than a 2x6. So that's kind of, I mean, a 2x6 or a 2x8. Those would be the only two choices. So you might as well just pick one. This one we'll want to look at that and make that a little bigger. So we've got to go to our, let's see, all this is in the properties. Here are my my 2x10s. I guess the easy thing or safe thing maybe, I usually go into the, I'll show you in a minute, the table that, the file that just lists all the input file. I just go into the input file and manually change it rather than going through this. But we can go through this too. If I clicked it, there's always a little delay here. Did I click it? Yeah, okay. All right. Although, okay, there we go. Now I got it. Timber, this was hem fir, wasn't it? And it seems like we were using select structural. We could pick a 2x8 and add it to the table. And we could pick a 2x6, add it to the table. And I think 25, if I remember right, was not too bad. It was okay for that. Okay, so now I've got these two in there. We can go ahead and assign them, if I can find that. Under groups, let's bring up the rafters, highlight all the rafters. Okay, let's make the rafters the 2x6. So assign to selected, assign, yeah, okay, good. And then we could go to the 2x8s and maybe make those the joists. So assign to selected, assign, yes. Okay, so I think I did that there. Like that. That's probably the, I guess, the safest way to do it. Let's see who these other beams are too. It looks like I played around with it a little bit already, didn't I? Oh, we can see which ones I changed. If you just click one, it should highlight it. Okay, so that one I already set a little bit thicker. See if we can find the one that failed. That one's probably a little over designed, I bet. I should have looked. That one, that was the one that failed. Okay, so there it is, a 21 by 675. Yeah, we pushed it up already too, didn't we? So I guess we need to push it up slightly more. And as I recall, you've got to manually type those numbers in. So we could just type it in. Well, let's see. Let's see if I can. If I do it here, I've got to totally change it and then. All right, we can do that. Let's do this. This is the. I just got to make sure I get the right. 24 VF. 24 FV4. Okay. Come on, where'd it go? Oh, there we go. Okay, timber. This is going to be glulam. 24 FV4 Doug fir. Oh, good. Okay, that one, and then this is what I got to change. So it was 21, and here STAAD's no help. You gotta go. I mean, it doesn't tell you what size. You gotta pick it, but you should pick one that's. So we already went 675. Let's just make it a little bit deeper. 675. Oh, I'll tell you what. I'll show you what we could. Do you remember it was 6% off, right? Right? Isn't that what the ratio was? 1.06 something. I'll show you. This is the spreadsheet, and I added this to it this morning. Oh, look, in fact, when I was playing around with it this morning, I already put in 106. So the area is controlling here, not the section modulus, if it's in shear. So the AX current, if I've got, let me check, see if I put the right numbers in. That was a 6 3/4 by 21. It says the area, oh, maybe I didn't put it in right, is yeah, I'm dyslexic. It's not right. No, this is the old value. And if I've got 7 3/4, that should be 141.8. So let me change that to 141.8. Okay, and then this was my ratio. So it's saying I have to have at least 150. So if I go to 22.5, it says I've got 151. 151.9 even. Okay, so let's try that. 22.5. So that'll be, oh no! Where did this happen? It's in feet. Okay. Well, here, wait a minute. Get that out of the way. Well, I should go back and change the units to inches, but I guess I could enter them in feet. What the heck? This is the width. What a pain. 6 3/4. Okay. 6.75 divided by 12. Okay, so that should be 5,625.5625 feet. All right. And then the depth, which was, see, I should have, before I opened that window, I should have checked my units. Or you could always go back and flip the units, but I just don't want to take the time to close it and bring it back up again. 22.5. Okay, so what's that going to be? 22.5 divided by 12. Says it's 1.875. So 1.875. Okay, so we got that. Add. That's going to put that over there. We can close it. Now we've got to assign it. It's already selected. So assign to selected. Assign. Okay, yes. Okay, so we made that correction. So we've upped that one. The other thing that I should correct, and I tell you what, I'm not going to do that through the interface here. It's just too much of a hassle. Let's close that. Let's look at the command file, and because I want to set my CVs. I don't think I did that. Ooh, I should have maybe noted what sizes these were. Wait a minute. Wait a minute before I jump into that. Let me. So this one that we just did is 6 3/4 by 21.5. Isn't that what it was? 22.5. Okay, the other ones, let's try to keep track of this so we don't totally screw it up. That is 5 1/8 by 21. So that's that one, right? 5 1/8 by 21. Okay. This one I made thicker. Yeah, that one failed in shear too. This is 21 by 675. Okay, so this one is 21 by, sorry, 6 3/4 by 21. And let's see who else we got on here. That's that one, 21 by 5 1/8. Okay, so that one was still 5 1/8 by 21. So I'm keeping track of this because I want to go through and get the CVs. And this is the one I just did there. So those others that aren't listed, where are they? Okay, that's also 5 1/8. Okay. And this one, where's that? Oh, that's the one we took out. We could delete it, actually. Should we? Yeah, let's get rid of it. Oh, what did I hit there? Oh, define. Delete, not define. Okay, get that out of there. So the bottom one, 5 1/8. Okay, so those are all of them, right? We got them all. Now we should go and put the CVs on those, and for that I will want the command file, and I have to save it. It says, okay, that's fine, and then it should bring up the command file. Okay, and we can kind of check. Here are the two things I added, and of course they made a mess of my nice table. That should have been the 2 by 8 should have been my joists. You don't really have to do this, but it makes it a little bit easier to read. Makes it a lot easier to read, actually. I get that? Not quite. Couldn't see what I was doing. That's not the right. Oh! Okay, there we go. And the other one, actually, this should come up, should give you the option to see that. I guess maybe if I delete that, usually a little screen comes up and lets you select it, but I guess not in this, whatever this mode is here. Okay, so it turns brown, so I guess we got the right ones. And then this was the other one that I added. That was beam, I didn't label them. Oh, here it's on this, isn't it? Beam 2. Is that the one that's missing? Okay. Okay. Beam 2. Okay, so now we know what those guys all are. Looks good. Beam 2, material constants. Okay, yeah, it didn't change that. Where'd my pen go? Okay. I'm not going to go back and change them all, but it took my names out again. All right, let's go down and look at this. This is the load duration factor. That should be the roof, right? And actually, I was thinking about that. This one would also have the roof load included on it, right? These rafters are bearing directly on that member. So that is that's beam number 5. So I'm going to put that on him too, just to be a little more precise about this. Oops. Beam 5. should get, oops, okay, I did it wrong. CDT of 1.25 for member beam. Okay, beam 5. Okay, so we got that. The other, all the rest of them have a CD of 1, right? Those are the only, the rafters. Oh, no, that guy there, 2. What the heck? What number is that? 4. Okay, alright, let's see. Can I do that? And maybe just change that to a 4. Okay, so we got the CDs corrected. The rest of them should all be 1, so I'm not going to worry about. I think that just shows the joist, but that's okay. They'll all be 1. This is what I really wanted to check, the CVs. Okay, so CV. I'm going to put it in. I forget what that was, what we put it on. It looks like something kind of random. Let's put it on member. We'll do it on each of the beams, right? So beam 1. Okay, so wait a minute. Didn't quite get that. Up. Where'd I go? What the heck? What happened? Okay, sorry. Right. Oh, but now I lost my, shoot. Beam 1. Okay. I've got it. There's beam 1. I'm just trying to set these for all of them. And what I'm going to do, this is where it's really convenient to have that name in there. You can just copy and paste them. There's 1, 2, 3, 4, 5, 6. 6 of them, right? So we go 2, 3, 4, 5, 6. Okay, so there they all are, and you just have to put the numbers in for each of them. And to do that, that's dependent on the size and everything, right? This is where I've got that handy little spreadsheet, if I can find it, that I just turned off. Let's see. Did it come up? Came up somewhere. Okay. Let's get that over a little bit. Doesn't want to let me see it, but there it is. Okay, so all you need to do, I mean, you could calculate this by hand. It's not that big a deal, right? It's just calculating CV. But this makes it a little bit easier since you've got to do it multiple times. Beam number 1. Golly. Let's label these so we know what we're talking about. Huh? This is number 1. This is number 2. This is number 3 down here. Then we got number 4, number 5, and number 6. Okay, so those are our beams as we're labeling them. And now we gotta get the sizes, and we gotta get the dimension. Oh golly! So this is 24 feet that way. This is 24 feet. Oh, they're all 24 feet. Ah, okay, that makes it easy. They're all 24 feet. Okay, so we just have to get the different sizes in there. So we got the length is 24 feet. The first one here up on top is 5 1/8. So let's do that guy. 5.125. And its D is what? 21. So it seems like a bunch of them were that, right? So that's 933. So this guy here is that, right? And we can see how many, there were some others that were that same size, right? Number 3, and number 4, and number 6. Okay, number 3. Didn't quite get it. Number 3, come on there. And number 4. And number 6. Is that what I said? Okay, and then we've got to get it on number 2. Where's number 2? That's the one we increased. So that's 6 3/4. Okay, so that we got to go up here. 6.75, and the depth is what? 22.5. 22.5. So that'll probably be a little bit lower. 901. Okay, so that is 2. .901. Okay, so we got that guy, and who's left? Number 5. Where's 5? By 21. Okay, so that was a little bit less. So that's just, oops, come on. 21. 907. Okay, almost the same. Not a very big difference, but we'll get it right. Okay, so you see the idea here. I mean, I've gone through, I've set, these are the things you want to set. We set the CD for the ones that are carrying a roof load. The others all carry a floor load, the 1.0 control, so I don't really need to worry about that. This is CF. That was the size factor we put on last time for the, hopefully that's rafters and joists. They, ooh, yeah, right, and we changed the size of them. Ah, okay. All right, we gotta correct that then. What do we make them? We made, and this is in bending, I'm just taking them out of the table here. The 2x8s are 1.2 for bending, 1.2. So the 2x8s, the 2x8s were the joists, right? Okay, so let's get those guys in there. Okay, and that was 1.2. Okay, and then the other one, well, maybe we can just type it in there. CFB. Alright. CFB. 2x6 is 1.3. Okay. 1.3 for rafters. Okay, so we got those, got the CBs, CFs, the CVs. Those are all the size things. Somehow it looks like I screwed this up. How did I manage to do that? Okay. All right, that looks right. This was the bracing, 5 foot on. This must be rafters and beams. Okay, I think I'll just leave those. And then we do the code check on everything. So that you've got all those parameters set that you need to set, and then we do the code check. And the code check's the last thing, and then that'll tell us again who passes and fails. And you can see, I mean, I'm not going to keep doing this over and over again, but your goal would be to try to get those efficient members for each one, nothing failing, and try to lower the utility ratio to something reasonable, like 0.8 or to where, ultimately what you try to do is pick the smallest member, right? You don't need to, this could take forever, typing things in. I'm not going to grade you on achieving the smallest member, as long as you get everything to pass and it's reasonably, nothing that's like way oversized. If it looks pretty good, I'll be happy. You should be happy. We'll all be happy. Okay, so we got it, right? We save it somewhere. Save it. We close it. And then we close this guy. And, what? 10 warnings? How did I suddenly get 10 warnings? Oh, huh? Oh, we double assigned materials. How'd that happen? Has already had a material assigned in the. Oh, those were. That's because I changed. Those are all the joists, I think, joists and rafters. Because I deleted it out in one place, but I didn't delete it everywhere. So there's some that are. I think they're still in there, but it'll take my last setting. The last setting assigned will be used. Okay, so that should be okay. I don't think that's a problem. Hopefully not. All right, so analysis, run analysis. Let's see if it's doing it. Yeah, it looks like it's running over here. Doing all the code checks. Okay, well now it only finds one warning. What the heck? All right, so that looks better. And let's view the output and see if anybody failed. Check for fail. Whoop, come on. Have to find all. What? I still have one failing. By 03 now. What was it? It was 06 before, and now it's by 0.03? It's the same one for sure. There it is, failing. What was it? It was like 179. I think that was probably it. Okay, yeah, I had that by 22 and a half. All right, well, obviously that one's got to be bumped up to the next biggest size. Didn't quite make it on that one, but the rest of them all pass. Like I say, the thing to check then would be, let's try and get a view that we can do this with. Oops. Sorry. I meant to do that. Results. Show. Turn that on. Say OK. And see. Yeah, there's the one that's still failing. Lousy thing. And see. Okay, these now are at 0.2, but we really can't go much lower than a 2x6. I'm surprised that it's showing it at 0.2. I'm a little bit suspicious, like whether that's really correct. These are showing 0.6. Okay, maybe we could go to a 2 by 6 on those. I'm not too convinced about that either. The other ones, this is a little bit hard to read. This one could be smaller for sure. Look at these. These are all 0.2. The shear again is the higher value. That's strange. I'm a little bit surprised that the bending moment doesn't control in this. You would think it would, right? Why is the bending moment showing so low? And here, okay, here it's a little higher. Here it's 0.8. Okay, that makes sense. This is only 0.4. Here it's 0.75. For the shear, it looks like the shear controls in these. So I don't know. Maybe we're not reading the bending correctly somehow. Maybe I'll go back and study that a little bit, because it doesn't seem to be giving me. That's one thing that's nice about output like this. I mean, you can look at it and see patterns and make decisions yourself, whether that's because there may be a mistake in it, right? I mean, that's the lovely thing about computer programs. You get one little thing out of place and it'll give you a wrong answer, and you don't know it, or at least you wouldn't know it unless you check the results. So that's one of the nice things about the results. To be honest, I would go back and really look at why is it not failing in bending. I'm surprised why these shear values control, because normally shear would only control on a very short span, right? And these aren't very short spans. It's 20 something, 24 feet. I don't know. Maybe it's okay. Well, I'll look at that myself too, and maybe Thursday, if I find some wonderful solution, I'll let you know. But otherwise, you can see, go through and try to size the members. Make sure you don't have any that are failing, like that guy right there. And otherwise, try to size them. Like this guy's 0.6. Okay, maybe that could go a little bit smaller. This one is 0.5 is the biggest, right? On this beam here. The joists, I don't think you could go any smaller than a 2 by 6 and a 2 by 8. Okay, maybe you could try a 2 by 6 for the floor too. But it seems, 12-foot span. Yeah, I'm surprised that it seemed like a 2 by 8 would be more in line with a floor load. Okay, so is that kind of a help? You think you can try it? How many people have actually opened up? A couple of you have. Okay, good. At least made an attempt at it. Make sure you can download it and get a copy, and then try this out. You can watch these lovely videos maybe and step by step through it. Supposedly this, the tutorial kind of, if you follow that, it's pretty good at step by stepping you through it, and then try to get it to run. So maybe next Thursday, if you have any questions, we could look at those, or if I figure out why it's not showing a larger failing for bending, I could tell you that too. Sound good? Okay. Otherwise, today, that took a whole hour to go through that. We got a little bit of time left. I'd like to go ahead and start in on the next topic, which was flitch beams. And because we do have a homework problem this week on flitch beams, I think, so it'd be good to Good to get that covered.